All right, so we've worked on the product rule. We still need to work on the quotient rule. And I have what I think is kind of a cool way to get the quotient rule without having to go back to the limit definition. So you can, it's actually kind of similar to the product rule, but I'm going to show you a different way to come up with this. So I'm just going to rename f over g. I'm going to call that q of x. So f of x over g of x is the same as q of x. And we're interested in q prime. So the goal here was to find the derivative of f over g, which is the derivative of q. Okay, so here's the deal. Anytime you have a quotient, you can always rewrite it as a product. So technically, you don't even need to memorize the quotient rule, but I find that it's easy enough just to have this one on hand as well. So here, if I want to rewrite it as a quotient, I'm going to multiply both sides by g. So I'll have q of x times g of x is equal to f of x. And then what we're going to do is we're going to take the derivative of both sides, which I don't think we've really said it that way before, but that's a very legitimate thing to do. If you have two things that are equal, you should be able to take their derivatives and they should still be equal. So here we get this cool product rule that we already know. We get the second, g of x, multiplied by the derivative of the first, q prime of x. And then we want plus the first, q of x, multiplied by the derivative of the second, g prime of x. And that's going to equal f prime. Okay, so if we remember, our goal was to get q prime of x, and q prime of x is showing up right here. So we can solve for that. So I'm going to go ahead and subtract q times g prime. So I have g of x times q of x, q prime of x, is equal to f prime of x minus q of x times g prime of x. And then I'm going to divide by g. So q prime is equal to f prime minus q times g prime divided by g. And this is pretty good, except the q was just a made-up thing that we used at the beginning. So I'd like to get rid of it, and it's fairly easy to do because we know that q is just equal to f over g. So here's what we end up with. I'm still not quite happy with it because I don't like the fractions in fractions, so I'm going to multiply top and bottom by g of x. And I will get q prime of f. Here, I'm even going to rewrite. So the derivative of f over g, otherwise known as q prime, is equal to, okay, we have to multiply everything by a g. So we get a g of x times f prime of x minus, here the g's cancel. We're left with an f and a g prime. F of x, g prime of x. And then on the bottom, we now have a g of x squared. And this is our quotient rule. Okay, so again, commit this to memory. If you notice, the top looks really similar to a product rule. It's just a minus in the middle instead of a plus. With the product rule, the order doesn't really matter so much, but here it really does matter. That minus needs to go with the fg prime. So this one, I'll tell you the way I say it, but a lot of people use a different way that I'll mention as well. So I look at this as the top and the bottom, and I say I have the bottom multiplied by the derivative of the top minus the top multiplied by the derivative of the bottom. I guess I can write it all out, over the bottom squared. So that's what I say to myself. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. One I hear a lot as well is people call them high and low. And they say low d high minus high d low over low squared, and that's kind of nice and rhymey, and people even make it a song, which you can look up on YouTube, I'm sure. But either one of those are good ways to try and say it to yourself to help it stick so that you can identify what goes where. Okay, I'm going to sneak in number 5 in this video because it's just a quick example and it gives us a new shortcut. So we did the derivatives of sine and cosine, but we didn't do tangent. And those are really the only 3 I do in calculus. If I ever ran into a secant, cosecant, or cotangent, I would just write them as a 1 over sine, a 1 over cosine, a sine over cosine, something like that. So I would just use sine, cosine, and tangent shortcuts. Okay, so the tangent shows up in the quotient rule part because tangent has a quotient identity that says that it is exactly the same as the sine over cosine. And we can use our quotient rule to find the derivative of that. So the quotient rule says if your big operation is division, you can make this big fraction bar and you get the bottom multiplied by the derivative of the top. Derivative of sine is cosine. And then you have minus the top, sine x, times the derivative of the bottom, which is the opposite of sine, over the bottom squared. Okay, so that's what we end up with. I think we can do better. So we have cosine squared x, and then this ends up being a plus sine squared x over cosine squared x. And if we remember one of our really big things from trig, the Pythagorean identity, cosine squared x plus sine squared x equals 1 no matter what x you choose. So I have a 1 over cosine squared x. Oh, I don't know why I wrote this in again. I want tangent. Or a secant squared x. And I don't really care which one you use. Use whichever one you like. Use both. 1 over cosine squared or sine squared or secant squared. All right, thanks for watching.